In the last video, what we did is we moved information from the register and stored it to memory. So because of how this processor is set up, in order to write from one memory address to another memory address, we have to take the memory and put it in a register, and then from the register, put it back into memory somewhere else. There's some processors that appear like they write from one part of memory to another part of memory, but very often they just hide this step. This is because, or partially because, the ARM architecture is a reduced instruction set computer. And so a lot of the instructions, most of the instructions, only take one or two cycles to actually process. The other processors that appear to be able to do this without any intermediate steps are complex instruction set computers for the most part. And the biggest difference between the two is that with the reduced instruction set computer, you depend more on the software to perform things, whereas with a complex instruction set computer, you rely more on the hardware to do things. And so let's actually see what this looks like. So in this exercise, what we're going to do is we're going to take a string saved into memory, and we're going to copy it from one place to another place. As you can see from the beginning, instead of doing the spaces to fill space in the output string, what we're doing is we're using our new fill command. And the format for that is the number of repetitions, the size of the repetition, and what we want to put in there. And since we don't really care what's there, we're just going to zero it out. Because this is 7 bytes, we could have just put .fill and 7 because 1 and 0 are the default values. So let's get started with this one. The first thing that we need to do is we need to load the input string and the output string addresses. Again, we'll use the load register. Let's put the input string into register 0 and the output into register 1. So this is going to be our main process. Read from output or read from input, store in a register, and then take from that register write to the output. We do this by using our load register byte, which we can take from memory and store information in the register. And so we'll put this in register 3 and the information at the address of register 0. And then we'll use our store byte to take the information in the register and store it into memory. And we'll put that where the address at register 1 is at. And then what we need to do is we need to increment both the addresses. By using our add instruction. And then we need to increment our output address using the add instruction as well. And so we just need to do this for every letter. So what we can do is just write it again. Because our addresses have been incremented, we're going to do the same commands. Read from our input. And then store that into the output. And then increment the addresses again. And so we're going to have to do this with every letter. Because we don't know anything about loops in assembly yet, what we can do for now is just copy and paste. And I think this is better for where we're at now because it forces us to actually see and think about everything that's happening right now. So if we take this is going to be our first M. If we copy and paste again, this is going to be our second M. If we take this again, this will be our E. If we take this again, this will be our R. And so if we just look at this, this is how we have to copy memory with the ARM processor. So starting at line 13, read the first byte into a register, and then we write it to the output. We could have done this by moving 4 bytes at a time, then 2 bytes at a time, but in the future exercises, we're going to be using this technique of incrementing through memory, and so I want to start introducing that here. So the next time that we go through it, we load the second byte, and we increment the memory again. This is lines 18 to 21. And then from lines 23 to 26, we read the next byte, save it to the output, and then increment our addresses. Again, 28 to 31, again, 33 to 36, and again, 38 to 41. The last thing that we need to do for this one, and we don't need to do it, but I do it because it's easier to read, is we need to put a line ending on the output so that when we write to the console, it looks nicer. And so we need to get this line ending in here somehow. In the last exercise, what we did is we actually put it and loaded it into memory. But for this time, we don't have it in memory already. But what we can do is just like we did with other immediate values, we can use a character as an immediate value. So into register 3, we can use this number sign and then single quotes and then /n. And if you've worked in environments where you've had to output line endings, you'll know that the /n gets escaped to an actual line return. And then what we can do is we can just store this byte to our output with the same command that we used before. And so we have now at our outstring address, we have, hopefully, we have the summer with the line ending. But what we need to do is, again, we need to write it. And so we'll set up the write. Again, for write, the number is 4, so we'll put that in register 7. Our first parameter is our file descriptor, and since it's going to standard out, it's always going to be 1. The next parameter that we have is our address of what we want to write, and we use LDR to load the address. So we're going to load this into register 1, and it's going to be the pseudo operation outstring. And then the last thing that we need to do is provide a length. And so SUMMER, and then the line ending is 7. And we'll invoke this with SVC and 0. The last thing that we need to do is exit the program. And the number for this is 1. So we'll put that in register 7. And the only parameter that we need is the error code, and it's going to be 0. And then invoke that with SVC and 0. And so hopefully, if we did this correctly, it'll work wonderful. First thing we need to do is assemble it. And so we'll use AS. Our output is going to be main.o, and our input is main.s. And then link it. Our output is going to be the executable. We'll just call it main, and our input is main.o. And if we run this, we get the expected output. So there's two things that we've kind of come across, and as we do more and more of these, we're getting into more verbose code. And so we have this thing now where we're writing a lot of the code over and over again. We're writing a lot of code that says load from one place, store in another place. And we did it 6 times in this exercise. And so the next time what we'll do is we'll start actually getting into how to loop this code. And not only how to loop it, but how to actually get out of the loops as well so that we're not stuck in a loop forever. But the other thing is that incrementing through memory seems quite problematic because we have to add the number of bytes that we read every single time. And we'll have to figure out if there's a better way of doing this. 2 things to think about for the next video.